Hello everyone. In this video, I'm going to show you how one can use dot product to determine whether two vectors are orthogonal or not. Let's see what is the question. The question says, determine which pairs of vectors are orthogonal. So we have three pairs of vectors, one in R3, one in R4, and one in R2. And the question is, check if these vectors are orthogonal or not. Okay, to solve questions like this, the first thing that you have to know is what I would like to call orthogonality test, which says two non-zero vectors u and v are orthogonal if and only if you dot them, you get number 0. That's fact one you have to know. And fact two is that what is dot product? Dot product is defined for all Rm, meaning that no matter how many components you have, if two vectors have the same number of components, you can dot them. And it is defined like this. If your vector u is u1, u2, um, and your vector v is v1, v2, and vm, then u dot v is defined by multiply corresponding components, add them. So corresponding components means that first component to first component, u1, v1 plus u2, v2, u3, v3, and so on up to the last one, um, vm. That's the definition of dot product. You have to know that. And then to check orthogonality, you have to dot two vectors, two given vectors. If it is 0, they're orthogonal. If it is not, they're not. Okay, so let's try to do A. To check orthogonality, I need to dot product two vectors. So 1, -2, and 1 dot 2, 1, 3. Dot product is multiply the corresponding components. 1 times 2 plus -2 times 1 plus 1 times 3. 1 times 2 is 2. -2 times 1 is -2 plus 3. And you can see that the result is 3. 3 is not 0, so that means the dot product of these two is not 0, meaning that these two are not orthogonal. That was test. We dot. If it is 0, they're orthogonal. If it is not, they're not. In this case, the dot product was not 0, so they're not. Second one. This time we are in R4, but doesn't matter. The test works for all Rms, and dot product, as I wrote there, is defined for all Rm. So let me just write this a bit lower. So -1, 2, 4, 2. And let me do the example here. So I have -1, 2, 0, 4 dot 2, 1, 3, 0. Dot product means multiply corresponding components, add them. So I have -1 times 2 plus 2 times 1 plus 0 times 3 plus 4 times 0. -1 times 2 is -2. 2 times 1 is 2 plus 0 plus 0. I have -2 plus 2 plus 0, which is 0. I had two vectors. I found dot product of them and I got 0. It means those two vectors are orthogonal. So they are orthogonal. Let me draw this box here. Okay, and the last one, I have vectors in R2. Test dot two vectors. If that's 0, they're orthogonal. If dot product is not 0, they're not. So I have to dot product these two. Dot for 2. Okay, so again, definition of dot product is there. Multiply corresponding components, add them. -1 times 4 is -4, plus 2 times 2 is 4. -4 plus 4 is 0. I found dot product of these two vectors. It is 0, means that these two vectors are orthogonal. Okay, very quick wrap up. Dot product is defined for all RMs, meaning that if you have two vectors with the same number of components, you can dot product them. And it is defined by multiply the corresponding components and add them. It will give you a number. If that number is 0, that means that two given vectors are orthogonal. If dot product is not 0, it means that they are not orthogonal.